Okay, so last time we stopped here. So today we are going to start here. So today we are going to assign. We are going to see how you can assign. You can assign a list to another list. Okay, no problem. So we are going to see how you can assign a list to another list. For example, here. Okay, let's read this code so that we understand it better. Here, you have created a list called list one, and then it contains one element. And that one element is number one. And then here, you have said list two is equals to list one. And then here, you have assigned list one. You have assigned the first element of list one, number two. You have assigned the first element of list one, the number two. Okay, let's run it and see what it gives us. 2. So this here, these 2 point to the same list. You are not creating a new list. You see, when we do variables, for example, if we have two variables, like let's do variables and then compare x is equals to 1, y is equals to x. So when we do this, you will be assigning the value of 1 to the variable y. Okay, the value of x to the variable y. But now here, we are not assigning this value to this list. We are just pointing to the same list. This one points to this memory location where the list is stored. This is what this does. So if these two point to the same memory location. So this is just one list, but it has two variables pointing to the memory location where it is stored. So far, have you understood what I have just tried to explain? Kindly write in the chat, because I need to know that you have understood what I have just said. I have said this list two points to the memory location of list one. You have not created a new variable. You have not created a new list like here. Okay, so let's start. We have said we have created a list which has one element, and it is called list one. And here we have come and said list two is equals to list one. So, and then here we have said we have changed the element of list one from 1 to 2. And then when we printed list 2, we have seen that it has changed to 2. So this is what I mean. This list 2 doesn't create a new list. It points to the memory location where the list is stored. You know, when you create variables like this, x is equals to 1, y is equals to x, here you have two variables. You have x and you have y. But if this could be lists, you could only have one list. And then this one, you could only have one list, and the list will be x. And then this y would point to the memory location where x is stored. So that means you have two variables, but one list. You have two names, but one list. Have you understood now? Have you understood? Okay, now we can move on. So we are going to do what is called list slicing. I want you to remember that the indexing of lists starts from 0. Okay, so a slice is an element of Python syntax that allows you to make a brand new copy of a list or parts of a list. So if you want to make a copy of a list, if you want to have 2 copies of a list, you do slicing. Okay, let's look at this example so that we understand slicing better. Here we have list 1, which has 1 element. And then here we have list 2 is equals to list 1, and then there is this slice. Then there is this slice, this end part here. This part captures everything. Okay, it captures everything in the list. It captures every element in the list. This is what this slice means. So here we have assigned the value of list 1 to list 2. So here we have 2 lists. We have list 1 and we have list 2. Have you understood? This part is a bit tricky, so I will need you to write in the chats if you have understood or not. Have you understood the difference between what we have seen previously and this? I need you to understand. This is assigning. Here, list 2 is assigned the value in list 1. So list 2 will have 1. List 2 will have the value 1. But the previous one pointed to the memory location where the list is stored. Yes, we have copied the value in list 1 to list 2. So if you want to copy a value that is in one list to another, you do this. So we have copied the whole list to list 2. Is it clear? Okay. So if you have understood that, then we are good to go. We can also copy some part of the list, like here. Here we have my list, which has 5 elements. Okay, Janet, welcome. Here we have my list, which has 5 elements. Now here we want to copy some part of the list, not the whole of it. So here we are copying 2 elements from this list, the second and the third element. So we will copy 8 and 6. That is what we are supposed to copy from my list to this new list. Let us run this code and see. Yes, as we can see, we have copied 8 and 6. So this is just a way of slicing a list. We can also create our own list and try to slice and see how slicing works. So we have this list M, and then now we want to slice it. Let's say we want to take the first 5 numbers. So to do that, and assign them to a variable X. So to do that, we will slice like this. Because we want the first 5 numbers. So we will put 6 here, because you remember Python stops just before the last index, this index. So here it will stop at 5 because we have given it 6. Python starts indexing at 0. That is why here it will stop at 5 instead of 6, because instead of counting 1, it will count 0, 1, 2, 3, 4, 5. Okay, let's run and see. Sorry, I haven't printed X. Okay, let's run and see. As you can see, it has copied the first 6 numbers and it has stopped at 5. 0, 1, 2, 3, 4, 5. So it has stopped at index 5, but it has copied the first 6 numbers. Why has it copied the first 6 numbers and it has stopped at index 5? This is because it starts counting from index 0. So instead of 1, it is 0. That is why it has stopped at index 5. Is slicing of lists clear? This part is very important. I need you to tell me if you have understood. If you haven't, we will repeat. Is this clear? Kindly type in the chats. Okay. Okay, now we can move on. So you can also slice list using negative indices. For example, we have our list X. Let's try with our list X. So this is our list X. When we slice with negative indices, for example, I do this. This will assign everything in this list apart from the first number, apart from the first element in the list. It will assign every other element in that list apart from the first element. So this -1 is used to refer to the last element of the list. Let us run this and see. Oh, sorry. I had forgotten to put that X before Y. Okay, let me clean this first, and then let me run it again. So it has taken all this up to 14. Sorry. It won't take the last one. But this -1 is used to refer to the last number, the last element in the list. So we said that Python slices until the second, okay, if it is given -1, it will stop at -2. This is -1, this is -2, this is -3, this is -4, this is -5. So negative numbers start with the number that is at the end of the list. They start counting from the end of the list to the beginning of the list. So if we have given it -1 here, it will stop at -2, because you remember the law of Python that it doesn't take the slice. When you've given it a number, for example, we gave it 6 and it stopped at index 5. So here we've given it -1, so it will stop at index -2, which is 14. And that is what it has done. We can try printing. We can try printing -1 so that you people understand, so that you people see what I mean. As you can see, it has given us -1, then is 15. 15 is our last element. So that means that when Python starts indexing, when you index negatively, when you use negative numbers as indexes, you start with the number that is at the end of the list, going to the number that is at the beginning of the list. Have you understood how negative indices work? Kindly type in the chats. I need to know that you have understood this. Okay, so you have understood. This is how negative indices work. They point to the last number in the list. We can try and run this and see. Let's try and run this code first, their code, and see what it will give us. As you can see, here we are expecting it to give us the output 8, 6, and 4, because we start slicing from 1 to -1. That means it starts from index 1 to index -2. Let us run this and see. As you can see, it has given us 8, 6, and 4. Okay, if the start specifies an element lying further than the one described by the end, from the list beginning's point of view, the slice will be empty. Okay, let us run this and see. This is what I mean. As you can see, we have an empty list. Why? Because it has started from -1 going to 1. So it has specified an element lying further away from the one described at the end. So this -1 element, it lies further away. Sorry about that. So this -1 element, it lies further away from this one. As you can see, -1 here is 2, and this one is 8. So it will give you an empty list because this -1 is further away in position as compared to this one. Is this concept clear? Kindly type in the chats. If you haven't understood, kindly type in the chats before I continue. Okay, we can move on. If you omit start in your slice, it is assumed that you want to get a slice at the beginning of the element with index 0. As you recall, our first example, we had omitted we had omitted the first element. Okay, let's run this code and see, and I will explain the code as we run it. As you can see here, we have my list which has 5 elements, and then here we want to slice from element 0 to 3. So as you can see, we have omitted the 0 that is supposed to be here. We can write it like this or omit it. So if you omit the value here, if you omit the value here, the Python will assume that you want to start from the first value, and it will place a 0 there. And then it will slice from 0 to the element you have specified at the end. So it will start from 0 to the index 2. So we'll have 0, 1, 2. So we'll have 10, 8, and 6. That is the slice that will be created. Let us run this and see. As you can see, it has given us 10, 8, and 6. Similarly, if we omit these 3, for example, if we write here 2 and omit the last element, Python will assume that you want to slice everything from index 2 to the last element. So yes, from index 2 to the last element. So it will be 0, 1, 2. So it will be 6, 4, 2. Let us run this and see. Yes, as you can see, it has given us here 6, 4, and 2. So whenever you omit something, or you omit a number, or you omit an index when slicing, Python assumes you want to get the whole thing. So here, if we omit both the start and the end, Python assumes you want the whole list. You want a slice of, not a slice, you want to copy the whole list. That is why we said before that this is used to copy the whole list to a new list. So when we run this, when we print the new list, you will see that we have a copy of my list. Sorry, wait. As you can see here, we have the whole copy of my list. It is 10, 8, 6, 4, 2, 10, 8, 6, 4, 2. Okay, we can also delete items in a list. For example, we can run this example and see. We delete items in a list by using the keyword del, like here. Here we have my list, which has 10, 8, 6, 4, 2. And then we want to delete the items 1 and 2 from the list. Like we have said, this is a slice. So it will delete items in index 1 and index 2 because it starts at 1 and ends at index 3. Okay, let's run this and see. As you can see, it has deleted 8 and 6. This is because this is index 0, 1, 2. So we are remaining with 10, 4, and 2 in that list. Okay, now if we want to delete everything in the list, what do? We just come here to the slices, to when we just come there to how you are slicing the list and do this. As you can remember, we have said that this takes the whole list. So when we do delete, we use the keyword del and then my list, and then we use this type of slicing. It will delete everything in that list. As you can see, it has given us an empty list here. So this is how you delete the whole list. So I hope you have understood so far up to where we have reached, how to slice lists, how to use negative slicing, and how to delete items in the list using the del keyword. We can also try to run this without the slice and see. As you can see, it is telling us my list is not defined. This means that this del keyword has deleted my list. Sorry, it has deleted the list we are using. So when we do this without indexing, we are deleting the list itself, everything. We won't have an empty list like the way we had when we did this. We won't have an empty list. We will have deleted the list itself. So when we run this, it gives us a name error and tells us my list is not defined. So far, have you understood? Kindly type in the chat if you haven't. If you have understood, please type yes. Oluoch, what are you doing? I can see you. Okay, let's continue. Kindly erase what you have written here, Oluoch, kindly. Okay, let's continue. There are operators in and not in. Okay, no problem. There are operators in and not in when it comes to list. For example, you want to check if an element is in a list, you use in. These operators give Boolean results, either true or false. If, for example, an element is in a list, it will give you true. If an element is not in a list, it will give you false. For example, here, we have my list which has 0, 3, 12, 8, and 2. And then here we have 5 in my list. We expect this to give us false because 5 is not in the list. And then here we have 5 not in my list. We expect this to give us true because 5 is true, because the statement is true. 5 is not in the list. And then here we have 12 in my list. We expect it to give us true because 12 is in the list. So these are just these two values are just used, these two, sorry, not values, these two operators are just used to check if an item is in a list or not in a list. As you can see, it has given us false, true, true. So the first one, we said it will give us false because 5 is not in the list. And then here it will give us true because 5 is not in the list. And then here it will give us true because 12 is in the list. So these are just simple programs that can utilize lists. Okay, let us explain. Let us go through this code and then we run it and see what it will give us. Here we have the for loop in the list. So here we have my list, which has 17, 3, 11, 5, 1, 9, 7, 15, and 13. So these are the elements in the list. And then here we have assigned largest, the element my list 0. So largest, here we have assigned 17 to largest because we have indexed it. As you can see here, we have indexed the list, taking the first index, which is index 0, and assigning it to largest. And then here we have used the for loop for I in range 1, comma, learn my list. So here we are saying I is in range 1. It starts with 1, and then the length of my list, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it is for I in range 1, and then here it is 9 because that is the length of the list. If my list I is greater than largest, then largest is equals to my list I. So this shows that if my list, if element I in my list is greater than the largest element here, then we assign that element to this variable largest. That is just what this code does. I hope you have understood what I'm trying to explain. Let me go over it again for anyone who has not understood. Here we have my list, which has these elements. Here we have my list, which has these elements. And then we have assigned the largest element in the list, which is the first element, which is 17. And then for I in range 1 to length my list, which is 9. We have counted and seen it has 9 elements, which is 9. And then we have used if my list I, if I is greater than largest, then we assign that I to the variable largest. If we run this, it will give us 17. We can change this largest to, let's use number 5. Let's see, 0, 1, 2, 3. We can assign it 3. So here it is supposed to give us 17 because 17 is larger than 5. Let's run and see. Let's run it. It has given us 15. I wonder why. And 17 is larger than 15. It is supposed to give us 17, but it has given us 15. I don't know why it has done that, but it is supposed to give us 17 because 17 is the largest number here, not 15. 15 is the second largest. Oh yes, I know why it has given us 15. We have started here in range 1. Sorry, we can change this range to 0, so it gives us 17. Here we had started with range 1, so it counted from this one up to the last element. And when it counted like that, it gave us 15. Sorry, I hadn't noticed that one there. Let me change it to 0. When we run this, it is supposed to give us 17. Yes, as you can see now, it has given us 17. So when we change the index here to 1, it will start counting from index 1 to the last index. And when we run it, it will give us 15, as you can see. I hope that is understood. Okay, let's move on. So this is another program. Let us write it as I explain it more and more. So here we have my list. Which has elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this list has 10 elements. It has 1 to 10 elements, and it counts from 1 to 10. And then to find, so here we have assigned the variable to find value 5, number 5. So we have a list of 10 elements, and then we have a variable called to find with number 5. Then we assign another variable found false. So we have 3 things here. We have a list which has 10 elements. We have a variable to find, which we have assigned it number 5, and then we assign found false here, as seen. And then we use the for loop for I in range So here we have a for loop for I in range length of my list. So for I in range 10, because these are 10 values in that list, we have 10 elements in that list. So for I in the length in range 10, found is equals to my list I equals to find. So here we have assigned the value found is equals to, if found is equals to my list I is equals to find. So here we are comparing I to find. So that means if we find 5 in that list, if value 5 is equals to find, which is equals to 5. So if 5 is in the list, it is found. That means found will be changed from false to true. If found break. You remember usages of break? It is used to break a loop. So if we have found it, then we break. If found, print. If found, we print element is found at index. Else, print absent. Who can guess what this loop will give us before I run it? I want you to write in the chats what you think this loop will give us before I run it. What will this loop print? I have explained the whole of it when I was typing. We have a list which has 10 elements. We have assigned the variable to find number 5. And we have assigned the variable found false. For I in range 10, so for I in range, the length of my list, because my list is 10, so we are going to move value by value in the list. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then, so if I is inside my list, that is for I in range, the length of my list, the values from 1 to 10. For I in range, the length of my list, if my list I is equals to find, if found, break. If found, print element is found at index I, else print absent. What do you think will be the output of this list? Kindly type in the chat. Okay, Kwame, thank you for your answer. Yes, Kwame, I think you are right. Let us run it and see. Yes, element is found at index 4. So Kwame, congratulations, you are right. That is what it will print as its output. So these are labs. I told you I will not do the labs for you. You go and do these labs. So key takeaways. If you have a list 11, then the following assignment 11 is equals to 12 does not make a copy of the list 11, but makes variables of 11 and 12 to point to the same list in the memory. So we have said that if you have a list vehicle 1, like here we have a list vehicle 1, it has car, bicycle, and motor. And then here we say vehicles 2 is equals to vehicles 1. We are not assigning the whole list, we're just pointing to the memory location of the list. This vehicle 2 points to the same memory location. So it will be the same list. This, we just have one list, but two variables pointing to the same memory. If you want to copy the whole list, you can slice it. You remember the way we sliced it? So if you want to copy a list or part of the list, you can perform slicing. This copies the whole list. This copies part of the list. It copies 0 and 1. So it copies red and green. You remember negative indices? We said that negative indices start from the last element of the list going to the first element of the list. So -1 is the last element of the list. -2 is the second last element of the list, like that. You remember when we said the start and end parameters of a list are optional. Like here, this will delete all the elements in the list. You remember we talked about in and not in. You can test if an item is in the list or not in the list. Okay. A list can be in a list. For example, M is equals to 1, 2, 3, 4, 5, 4, 5. This is a list in a list. You can print M and C. As you can see, this is a list contained in a list. So this list will be, so if we have this list will be index 0, 1, 2, 3. 0, 1, 2. Yes, this list will be in the index 3. We can try slicing it and see. So for example, you want to assign YM index 1 to 4. Let us run it and see. Sorry, I haven't printed Y. Let me print it. Let me print it out. As you can see, it has given us 2, 3, and the list inside the list. So a list can also be contained inside a list. So this is creating a chessboard. For example, you want to create, so if you want to create a list of lists representing the whole chessboard, so if you want to create a list representing a chessboard, you can use this code to create it. This is just an example of lists in a list. Okay, let me check. Oh, okay, so empty is not defined. We can try defining it and see. Let's print board and see. Yes, so this is a whole list, and it has also another list inside. I want you to note, as you can see, this is also another list, and it contains 2 lists inside. It contains 2 lists inside. As you can see, this is another list, and it contains 3 lists inside, like that, like that, like that. So we have, the last list contains 8 lists inside. So you can go and try this example also by yourself. This is also another way. This is another way of writing nested lists. This one, board is equals to, let me copy it and paste it here for you to see it easily. So this is another way of writing this whole code here. This whole code can be written like this. Board is equals to empty for I in range 8, for J in range 8. You can write it like that. Let me assign empty so that it doesn't give us an error again. Sorry, I haven't printed board. As you can see, it has printed 8. It has printed 8 lists. And then inside each list, there are 8 zeros. For here, 1, 2, 3, 4, 5, 6, 7, 8. So here, empty for I in range 8. So it has printed 8 zeros in every list. And then it has printed 8 lists. It has printed 8 lists in that one whole list. So it is just like this. The only difference is that this one prints the last row only. As you can see, it has printed for us the last row only, but this one printed from the first, the second, the third, the fourth, the fifth, the sixth, the seventh, until the eighth. But this one has printed the last row only of this code. So you can go and play around with these two and see. When you play around with them, you also get to learn more about lists in lists. So far, have you understood before we move on? Please type in the chat if you have understood before we move on, so that I know. Okay, we can move on. So here, we have assigned the variable empty an hyphen, and then rook is equals to rook. We have assigned the value rook, and then we have assigned board an empty list. And then here for I in range 8, so I counts from 1 to 8. Row is equals to empty, that is this one, this variable, for I in range 8. Board dot append row. So we append this inside this empty list here. So, and then here we assign the value 0, 0 is equals to rook, 0, 7, rook, 7, 0, rook, 7, 7, rook. So this, here we just index board. The reason why it looks like this is because it is a 2-dimension array. So this is the row and this is the column. So row 0, column 0 will be rook. Row 0, column 7 will be rook. And that will be, so that will be this, row 0, column 7 will be rook. Row 7, column 0 will be rook, so that will be here. And then row 7, column 7, this is this. So I want you to go and read this table and try to understand it. This is a 2-dimension array. It has rows and columns. Okay, these are rows, these are columns A, B, C, D, E, F, G, H. Yes, let me run this and we see what it gives us. So this is what it gives us. Yeah, so this is the output of this code. Go and if you understand this table, it will be easy for you to understand this output. So I know this is a bit confusing, but just go and try to understand this table. Like this is row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3, row 0, column 4, like that. Row 1, column 0, row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 4. So just go and try and understand this table. If you have any issues understanding that table, kindly reach out. I will help you. So we can try and run this and see. This is just another application of lists. So here, imagine that you develop a piece of software that for an automatic weather station. The device records the air temperature of an hourly basis and does it throughout the month. This gives you a total of 24 times 31, that is 744 values. Let's try to design a list capable of storing these results. So here we are trying to design a list capable of storing weather readings throughout the month for an hourly basis. That is, that the month has 31 days and the hours are 24. So each hour it gives us a reading for 31 days. So that means the list will have 744 values. First, you have to decide which data type will be adequate for this application. In this case, a float. So here we will use a float. It will be best suitable since the thermometer is able to measure temperature with an accuracy of 0.1 degrees Celsius. This is why we will use a float. Then you take an arbitrary decision that the rows will record the readings every hour on the hour. So you say that the rows will record the readings every hour on the hour. That means on the start of the hour, it is red. At 12 a.m., it is red. At 1 a.m., it is red. At 2 a.m., it is red. At 3 a.m., it is red. At the top of the hour. You can't read at 12 a.m., then at 12, then at 1:30. It has to be uniform. If you are reading at 12, read everything at the top of the hour. 12, 1, 2, 3, 4, 5. You can't read 12 and then 1:30 and then 2:45 and then 3:50. You have to be uniform. If you decide that you are reading it at 12:30, it will be 12:30, 1:30, 2:30, 3:30, 4:30, 5:30, like that. So let us run this code and see. Sorry. So this list contains a lot of 0.0, okay? Sorry about that. So this list contains zeros. But now when you have values, when the readings are taken, the readings will replace these 0.0s. For example, when they are taken on the first hour, the readings will come here. On the second hour here, on the third hour here, here, like that until the whole list is full. This is just another example of an application of lists, how lists are used. So they can also be used to create 3-dimensional arrays. We can try to run this and see. Oh, it is already here. Okay, let's read. Imagine a hotel. It's a huge hotel consisting of 3 buildings, 15 floors each. There are 20 rooms on each floor. For this, you need an array which can collect and process information on the occupied free rooms. So here we have a huge hotel. It has 3 buildings and it has 15 floors on each building and then 20 rooms at each floor. The first step will be to type the type of this array elements, in the case Boolean values. So here we are trying to see if the rooms are free or occupied. So it will be, we will use occupied. It will be true if it is occupied. It will be false if the room is not occupied. Okay, step 2, calm analysis of the situation. Summarize the available information, 3 buildings, 15 floor, 20 rooms. So this just states that after creating our lists, after getting the data, we just summarize the information. Let us run this and see. Sorry, I haven't, let me print it out. As you can see, we have assigned false. False is the default value here. False is our default value. So when a room is occupied, it will change from false to true. As you can see here, we have 3 lists. The first one is this one. The second one is this one, and the third one is this one. We can try this and see. We can also say rooms. Let's try assigning the first one and see. As you can see here, okay. Here we have changed this value to true. This other value is, this is the first list, the second list, the third list. It is very far, but as we can see, okay, let me remove this. Let's just use this one because the other one is so far. It is hard to look for it. But here, as you can see, we have changed this value from false to true. So that is how these lists work. You first give them a default value, and then when the values change, you assign it a new value. Like here, you can see it has been changed from false to true. Okay, so what are the takeaways that we have learned from this? List comprehension allows you to create new lists from existing ones. We have seen this expression for element in list if condition. We have done this, which is actually equivalent to this for element in list if condition expression. As you can remember the example where we had a board. You can remember that example that I showed you. So this, I told you this is similar to this, which is true. This is a number. This is just another example. Cubed for num power 3, num power 3 for num in range 5. So that means here for num in the range 5, every number will be every number in for num in range 5, every number will be raised to the power 3 here. That is what this means. You can also use nested lists in Python. You can create nested lists in Python. We have seen you can create multiple dimensions. You can create a list with 2 dimensions. You can create a list with 3 dimensions. And we have also seen some application of lists. Okay, we have completed this module. So I would kindly advise, I will tell you to kindly go and do the quiz and the tests in this module 3, and please send in your results before Tuesday. Kindly also go through the module again. Anywhere you have not understood, reach out and ask me. I will help you. Is there anyone with a question? If you have a question, please ask before we end the class. Is there anyone with a question? Okay, so please go do this quiz and this test, and also go through that module again. Please, when we meet again, we will start module 4, the last module. We will do this. So thank you for attending the class. Thank you for listening. See you on Tuesday. And please send in your test results and your quiz results before Tuesday. Thank you.